Ready-made maths YouTube mathematics training videos. Teacher and teaching assistant training. We're now at the final day of mental multiplication, and we're going to look at the strategy JUMP, which is all connected with multiplying and dividing by 10, 100 and 1,000. We're going to start off in the ready-made maths classroom, and then we're going to spend the majority of this session looking at an ICT resource and a mathematical song that really supports this objective. As you can see, and as we've mentioned each day, these are the strategies that we've been going through over the previous sessions. We actually started off with an overview of all of the strategies, apart from actually the one we're looking at today, JUMP. What we then did was we looked at the strategies one by one. We started off with reordering. We then looked at partitioning, at rounding and adjusting, at factorising, at a whole range of doubling strategies. We then looked at my favourite, manipulate the calculation, which is usually doubling and halving together. And in the previous session, we looked at the strategy of multiplying by 10, 100 or 1,000 and then halving. Today, we're at the final cool strategy for mental multiplication, which looks very specifically at the idea of what do we do when we multiply or divide a number by 10, 100 or 1,000. In particular, when we start to move towards decimal numbers. Hello and welcome to the Ready-Made Maths YouTube channel for the final one of our big suite of multiplication videos. We're now up to day 9, and what we're going to be looking at today is a strategy called JUMP. We're not going to be spending too much time in the classroom today. I'm just going to briefly introduce JUMP and link it into multiplication and actually division as well. And then we're going to actually spend most of the session today looking at an ICT resource and a song that will explore this particular concept. Where does JUMP come into the equation then? Well, JUMP comes in for the objective of multiplying or dividing by 10, 100 or 1,000. And what I first want to do is just address two common misconceptions that you often hear. Teachers and teaching assistants and children and parents. You hear it, from many people. You hear these two phrases that are used an awful lot. When you multiply by 10, you add a 0. When you multiply by 100, you add 2 zeros. You hear that an awful lot. Now, is that right or is that wrong? We'll briefly explore that. Something else you then hear in year 5 and 6, when you multiply decimals by 10 or when you multiply decimals by 100, you move the decimal point. The number stays where it is and the decimal point bounces all over the place. I certainly remember from my time at early and secondary school, my maths teacher having these bouncing decimal points that kind of flew all over the place. They used to start with a number and bounce a decimal point to the left and the right. Again, we're going to explore very shortly, is that the case or not? But before I kind of address that, if that's something you have said yourself in the past, add a 0 or move the decimal point, my first question is why? Why have we said that? Is it just because what we've learned before, or is it something we actually believe? So let's have a look at the 4 calculations that we've got here. 6 times 10, 15 times 10, 1.3 times 10, and 2.46 times 10. And let's try adding a 0 or moving the decimal point. So we'll just pause for a minute, have a look at those, and just discuss if there's anyone with you, why we say that and whether or not it's correct. The first rule, 6 multiplied by 10. Well, if we add a 0 to the 6, it does give us the number 60, and 15 multiplied by 10 does give us 150. So it looks like we just had a 0. The problem is we're not taking into account whatsoever any of the place value. We've just thrown a 0 on the end because that's a rule that we've been taught. And the problem actually starts to occur if you've taught that in Key Stage 1 or lower Key Stage 2, you'll just stick a 0 on the end. Then when we get to decimals, suddenly it all changes. Let's follow that rule. 1.3 times 10, add a 0, and we end up with 1.30. 2.46 multiplied by 10, add a 0, we end up with 2.46. We followed that rule, and actually the answers are now wrong. 1.3 multiplied by 10, we've now ended up with what we started with, and the same with the following one. So it definitely isn't add a 0. It looks like we add a 0 when we're looking at whole numbers, but actually we're not really adding a 0. We're making the number 10 times bigger, and the 0 is then used as a placeholder, which I'm going to show you in a few seconds. The second phrase that we came up with, move the decimal point. Now for the first 2 examples we haven't got a decimal point yet, so we'll go to the third one. 1.3 multiplied by 10, well the answer is 13.
We could obviously call that 13.0, and it does appear that the decimal point has bounced. Let's look at the next one. 2.46 multiplied by 10, and again, the answer is 24.6. So in both those instances, it does appear that what's happened, well, the decimal point's moved. It's gone from there to there. And obviously when we divide by 10, it goes the other way. But is that what's really happened? When we've multiplied the 2.46 by 10, has the decimal point moved, or has something else moved? And again, that's what we're going to examine shortly using the ICT resource. Let's very, very quickly then look at the example 15 multiplied by 10. What we're looking at here is the number 15. What do we mean to multiply by 10? Well, there are two ways that people talk about multiplying by 10. Either get 15 lots of 10, or get 15 and make it 10 times as big. The correct interpretation, if we use the word multiply, I'm going to take 15 and multiply the 15 by 10, is definitely to make 15 10 times as big. But you will get the same answer by getting 15 lots of 10. The reason I always prefer using in effect the correct interpretation is we're going to start with the 15. We're not starting with 10. We're starting with 15 and we've got to times it by 10. We've got to multiply it by 10. I'm not starting with 10 and then suddenly getting 15 lots. 15 is the number that I see first. So I'm going to operate on the number 15. Here's 15. Let's make it 10 times bigger. So over here, we've now got an example of what 15 multiplied by 10 actually looks like. I've taken my 15 and I've made it 10 times bigger. So I've made the 10 times bigger, and I've made the 5 10 times bigger. In effect, I've got 15 10 times. Let's have a see what the answer actually then becomes. I put all the 10s together. We know the answer anyway, but 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And if we look at what we started off with, here's our 15 that we began with. There's our 10 and our 5. We can see that was the 10 we began with, and this is 10 times bigger. We'll do exactly the same with the 5s, just to prove that's what we've done. So again, what we've done here, we've got the 5 and we've made it 10 times bigger. Obviously what we can then do is put the two 5s together to make another 10, those to make a 10, those to make a 10, those to make a 10, and those to make a 10. Similarly, we can put all those 10 10s together and make 100. We can take those now 5 10s and make 50. So what we've actually done there is we've taken our 10 and make it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times bigger, but it's now 100. It's no longer 10 10s, it's 100. We've taken our 5 and we've made it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times bigger. It's no longer 5 1s, it's now 5 10s. So we've gone from 5 10s or 50. It's no longer a 10, it's 10 10s or 100. It's no longer 5, it's 5 made 10 times bigger, 5 10s or 50. Let's have a look now at how that looks over on the board. So we're looking at 15 multiplied by 10. And this is again why I think we should be saying it that way rather than saying, oh, 15 lots of 10. No, it's 15 multiplied by 10 because we can see what just happened. We took the 10 and we made it 10 times bigger. Therefore, it became 10 10s, 100. That's what it became. That's what actually happened, and that's what we just proved. We then took the 5 1s, and we made those 5 1s 10 times bigger, and we ended up with 5 10s, or 50. That left us with actually no individual ones. We know overall we've got 150 ones, but we've got no specific individual ones. We've now got 100 and 5 10s. If we'd have read it the other way and said 15 lots of 10, we would still have got 150, but we wouldn't have made the 10 10 times bigger, or the 5 10 times bigger. We'd just have got 15 10s, put them all together, and then done the exchange. The final picture would have looked the same, but we wouldn't have been doing it by multiplying, we'd have been doing it by, as I've said before, lotsification, so many lots of. I think it's far better to show it this way, and the children can really understand what's happening when we're doing a multiply by 10. How we can multiply by 10 using resources, and looked at actually adding a 0 is not the right way to say it, because obviously when it comes to decimals that doesn't apply. We prove to the children what's happening. We show them specifically what happens when we make something 10 times bigger or 100 times bigger, and we show what's happening, that the digits are moving. The digits are going one place to the left, the digits are what are actually shifting, and in effect you could say the digits are jumping. They're jumping one place to the left because they're becoming 10 times bigger. What we're going to do now is we're going to go to the ICT, to the PowerPoint, and to a little song, and we're going to see how that same rule applies as we develop into decimals as well.
So let's have a look. It's a lovely ICT resource that I've been using for so many years now, called Moving Digits. This was one of the National Numeracy Strategy's original ITPs. I've been using it for so long, I can hardly remember when I originally started using it. It was well over 10 years ago. It's a really, really good resource for helping the children with multiplying and dividing by 10, 100 and 1,000. And it really lets them see what happens with the digits moving, not the decimal point, and also with the idea of adding a zero, or what we're really doing, which is making the number 10 times bigger. What it allows you to do is to select some cards at the top by clicking on them. So I'll just select 37. Now I can put the 37 either on the bottom, like so, or I can put the 37 on the top. If I put it on the top, what will happen now is you'll notice if I put the 3 down, it actually does fill the zeros in. So it tells you that that is now worth 30. If you put it on the bottom, you'll notice it just puts the digit in, and you've got to then discuss with the children, what do you think it's worth? So you've got both those options of using the resource. So it can just be used as a place value resource. So often I will just use it for that purpose. We're not going to use that today. We're going to look at how it can be used for multiplying and dividing by 10. Now at the moment we've got these column headings at the top: 10,000, 1,000, 100, 10 and 1, and then 0.1, 0.01 and 0.001. We can change those headings to the old-fashioned HTU, which I'm not particularly keen on. But what I do like is the 10th, 100th and 1000th options that you've got here. It's a shame that they haven't got an updated version of this, because personally, you can remove them all completely. I would prefer to have the 1, the 10, the 100 and so on, alongside, clicking on this again, the 10th and the 100th. As it is, we've kind of got to choose either or. So I'm going to go with I don't want the HTU, so I'm going to go with the option of the 1s, the 10s and the 100s, and so on. I can also, by clicking on this icon here, just put the columns in as well. I can remove the decimal point by clicking on this icon if I want to, or I can put it back in. I will leave the decimal point in for the time being. Let's first of all look at what we can do just to show multiplying by 10. Now what's nice about this is as I click the icon for multiply by 10, it only moves the numbers on the top. It leaves the number on the bottom exactly where it is. So what I could say is I've got the number 37, and what I'm going to show you now on the top is what happens when I multiply by 10. And what you can see is, although you can see obviously a 0 appear, you can now see why. You're not just sticking a 0 on the end. You can obviously discuss in class, like we've done in the classroom, what actually happens. The 3 gets 10, sorry, the 3 10s, or the 30 gets 10 times bigger. 30 times 10 is 300. The 7 gets 10 times bigger. 7 times 10 is 70. So you can see what's happening here is the 3 gets 10 times bigger, becomes 300. The 7 gets 10 times bigger and becomes 70. And therefore we have to put a 0 in to show that there are now no individual 1s. We're not just sticking a 0 on for the fun of it. It has a purpose. It's acting as a placeholder. If I reset this, even if I started with a number like 6 and just drop that in, what happens when I multiply 6 by 10? Well, obviously the 6 get 10 times bigger. I get 6. I get 6 repeated 10 times. 6 multiplied by 10, or 10 groups of 6. I end up with 60. But it's not just sticking a 0 on the end. There's a reason. It's to show there are no individual 1s. Yes, there are 60 1s altogether, but now we have 6 10s. Now you can see, no matter what number we choose, as the numbers get bigger, let's just go for 428. And again, what's interesting here, if I put the 4 there, it will show me it's worth 400. If I put the 4 on the bottom, I can ask the children, what is that 4 now worth? If I put the 8, I put the 8 down here. Again, I can ask the children, what number do I actually have here? I've got a 4 in the hundreds and 8 in the ones. On the top, obviously, it will tell you it's 408. I'll put the 2 in, and I'll put the 2 in. What I'm going to do now is I'm going to multiply the top number by 10. And now we can see what's happened. I'll divide it by 10, multiply by 10. Divide it by 10, multiply by 10. What's happening? The digits are jumping. The digits are jumping one place to the left and one place. Sorry, one place to the right, one place to the left. what happens when you multiply by 10? Each of the digits seemingly moves one place to the left. Why? Because they're each getting 10 times bigger. Why? Because we're multiplying by 10. The 400 becomes 4,000, the 20 becomes 200, the 8 becomes 80, and obviously we leave a 0 there to show there are no individual ones. We do know from the place value week there are actually 4,280 ones, 428 tens, 42 hundreds, and 4,000s. And we can have all those discussions as well. But what's also really nice, I'll just put the divide by 10, put them back together. I can also multiply by 100. So I just get rid of the 4 for the time being and start with 28. 28 multiplied by 10, we can see what happens. The digit jumps one place to the left. 28 multiplied by 100, and look at that. Divide by 100, multiply by 100, divide by 100, multiply by 100, divide by 100, multiply by 100. Now we can clearly see what's happened. The 2 hasn't got 10 times bigger, it's got 100 times bigger. So that 2, which is worth 2 tens or 20, now becomes 20, 200, 2,000. The 8 also gets 100 times bigger. It goes from 8 to 800. So we can see clearly that each of the digits has moved 2 places to the left. If we divide by 100, they move back 2 places to the right. And again, you can see we've had to put zeros in there to show there are no individual tens and no individual ones. Although obviously in total there are 280 tens and 2,800 ones. So it's an absolutely lovely resource just to let the children see what really is happening when we multiply by 10 and divide by 10. If we start off with 2,800, let's divide it by 10. So again, I'm going to put a 2 there, my 8 there. I'm going to put, I put a 0 in there. So I can now see 2,800 and divide by 10, what happens? And you can see what happens, multiply by 10, divide by 10. Multiply by 10, divide by 10. Multiply by 10, divide by 10. Same idea, I'm now going to divide by 100. And what happens there is the digits jump 2 places to the right. Theoretically, the zeros are also moving to the right, but we don't need the zeros after the decimal point, and so they kind of, it looks like they've disappeared. But you can see what's happening really is that the 2 and the 8, it goes from 2,800 to 28. So really, really nice resource. Now, what else can you do with this resource? Well, if I reset it now, and this time set you up a number like 4.5, we can see now, as we proved in the classroom, that it really isn't about adding a 0. Watch what happens when I multiply by 10. It really does show what happens. The digits jump one place to the left. Each of the digits has got 10 times bigger. My 4 is now 40. My 0.5 or half is now 5. So it's 5 tenths, and it's now 5 ones. You see what's happened, divide by 10. Multiply by 10, divide by 10. So you multiply by the 10, the digits jump one place to the left. Divide by 10, they jump one place to the right. But what we can definitely see now is that decimal point is not flying all over the place. The decimal point isn't moving here, there, and everywhere. The decimal point is a place value holder, and that's what it should always be. There are no children that should be taught move the decimal point. If we're teaching them that, we're teaching them completely incorrect mathematics, and we're losing the place value completely. The decimal point is a place value holder between the wholes and the fractions of numbers, the decimal fractions. So what's happening is the digits are moving one place to the left. You multiply by 100, the digits are moving 2 places to the left. Divide by 100, 2 places to the right. So if I finally make a little bit a bigger number now, I'll use a 3 over there, a 3 over there, put a 7 into place. So we've now got the number 74.53. We multiply by 10, the digits jump, it's now 745.3. Divide by 10. Multiply by 100, the digits jump 2 places to the left because each number gets 100 times, each digit gets 100 times bigger. The 7 is no longer worth 70, it's worth 7,000. The 4 is worth 400. The 5 tenths is now worth 5 tens or 50, and the 3 hundredths is now worth 3 ones because it's got 100 times bigger. Again, really powerful resource, very, very easy to use, and there's so much questioning and reasoning that you can do just with this resource. I'll often spend 20 minutes just with this resource, on a place value lesson, just talking to the children, giving them their own place value cards, letting them move digit cards around a place value chart like this, giving them different things to do each time so that they are physically moving digit cards to the left and to the right to discuss multiplying by 10, dividing by 10, multiplying by 100, dividing by 100, and so on. Really, really worth doing because it really establishes what's actually going on. Number one, we're not just adding a zero, and number two, it's the digits that move, not the decimal point. Our final little resource, which actually backs up the same principle, is one of the songs Jump from the Number Fun portal. In a similar way to the ITP, I've been using Jump for well over 10 years now. I've used it in so many classes, I've lost count. And when I usually use this particular song, I have the children stood up and they jump alongside to the left and the right with me while the activity takes place. You can see on the Number Fun portal, which I'll show you shortly, some children doing this particular song as part of a mathematics activity day with Dave Godfrey, who writes the songs. Again, if you're interested in this, you get hold of this from the Number Fun portal. Let's have a little play and see what happens.
When you multiply or divide by 10, the digits jump, the digits jump. When you multiply or divide by 10, the decimal point, it never moves. Jump to the left when you multiply by 10. Jump to the right when dividing by 10. I said you jump to the left when you multiply by 10. Jump to the right when dividing by 10.
And I think you can see how catchy that is. It sticks in your head so well. I've been into many schools who kind of, I've been in and done the song with them. I've gone back a few weeks later and the children just going, jump to the left when you multiply by 10. Jump to the right when dividing by 10. It's completely stuck in their head. It's so catchy. And obviously, if you've done it in class with them and have them jumping to the left and the right, it works even better. I've often used that song alongside the ITP, so I can click the ITP as the children are singing the song. The best use of this is when I've seen Dave Godfrey himself do this with children when they've been wearing football shirts with numbers on the back, and they've used the football, as you can see here, as the decimal point, and they've kind of jumped to the left and the right using those football shirts as numbers. Obviously, works really well. As long as you're facing the opposite way, don't face the people that are singing. Face the opposite way. So when you jump into the left, the numbers or the digits do actually jump. How this song then develops, I'll just move it on a little bit as it gets to verse 2.
Never moves. Jump to the left when you multiply by 100. Jump to the right when dividing by 100.
You can see there, it then moves on to 2 jumps to the left and to the right. Great fun when you're standing up. And the third verse, I'll just take it on a little bit further. It's that point there. Let's have a look.
The digits jump when you multiply or divide by 10. The decimal point, it never moves. Jump to the left when you multiply by 1,000. Jump to the right when dividing by 1,000.
And again, you've got to be quite a quick jumper, but to do that one in class is really good fun. Just make sure the children have left enough space or take them to the hall to do the activity. Give them digit cards, give them football shirts, let them have a decimal point, let them practice being the different digits and jumping to the left and the right. Make it active so it's so fun that the children can't forget it. That's how it's going to stick in their head when they're playing, when they're having fun, when it's active or interactive. That's what makes the learning really powerful. So you've got an ICT resource, you've got Jump as a video presentation, but actually I would generally not use this particular presentation. I would probably, for this song, I'll just come out of it for a minute. We'll put the original song on the full track and use that with children in the hall, or put the backing track on, as well. I'll probably just use the full track for this. What's also quite interesting is the teacher ideas pack. It's really nice because this does allow you to download lots and lots of ideas for how to play and use the song and the video, the score, but also it gives you some sets of cards that you can use alongside the activity, which you can give out, put into class, and have the children playing one of the games as described. There's also an example of one of those sliders that you can create for the children as well. That's all free if you join the Number Fun portal. Each song has got its own set of resources. And here's a little video.
Jump, jump to the left when you multiply by 100. Jump, jump to the right when dividing by 100. Jump, jump to the left when you multiply by 100. Jump, jump to the right when dividing by 100.
And you can also see the class teacher there with the football actually playing the part of the decimal points. So we can see at the moment this is the number 549. When the children jumped 2 places to the left, it became 54,900. And again, that can be done with any number, with different shirts in class, or just holding digit cards up as well. Many ways you can do it. Really, really good song. And I hope you've kind of found the activity today a little bit different to some of the other days, a little bit more interactive, because we are covering a slightly different concept. So, as we've just looked at, we've seen the Moving Digits interactive teaching program, which is available from pretty much most local authorities. I will put this onto the multiplication Dropbox link that I'm going to be sending you at the start of next week, that contains all the resources from the multiplication videos that I've put out. So this will be one of those that's available on that. And then the jump song that we did, which obviously you can get from the Number Fun portal. And that's the login details there.
Thank you so much for joining me for Jump, and I hope you did enjoy the songs and the activities that we've just been doing. That's the end of all of the multiplication videos. We've looked through a whole range of different strategies. We've looked, I think, 9 different strategies that we've covered over the course of the session. So I hope if you are in Key Stage 2 that you'll be able to make use of those and start to develop them, so they're the sorts of strategies that you yourself are using regularly, and also starting to build up with the children. So thanks very much for that. And can I just preempt tomorrow's video will be a little bit different than the ones that we've been looking at previously. It will just be a very short video introducing what I'm planning on doing over the next few weeks between now and the summer holidays. What I'm going to be doing is moving away for a while from the CPD training videos, and what I'm going to be doing instead is actually putting on some online training. So what I'll be doing tomorrow is just a short video explaining the sorts of online training that I'm hoping to put on between now and summer. So hopefully if you've enjoyed the videos, you might be up for coming on some of those sessions. And obviously, if you know any other people who might be interested in training, that'd be brilliant if you could ask them to have a quick look at that video tomorrow. Obviously, I will also be tweeting out all the details as well, so that anyone who doesn't see the video will also be able to see what I've got coming up. So again, thank you so much for any of the videos that you've watched and for bearing with me for all of the different multiplication strategies that we've been using. And see you all tomorrow to have a look at the upcoming training plans. Thanks very much, and I'll see you soon.
And thank you so much for joining me for all of the multiplication videos that we've looked at over the past few weeks. I hope you've enjoyed Jump and also many of the other strategies that we've covered. That's the end for the time being of the larger CPD training videos that I'll be putting together. Over the last few weeks, obviously, we've looked at mental calculation and addition, we've looked at place value, we've looked at EYFS training, we've also looked in quite a lot of depth at mental multiplication. Don't worry, there will be plenty more videos coming up in the future, including lots of mini videos over the next few weeks, where I'll be looking at using resources. The larger videos are going to be kind of coming to a halt for the time being, because what I'm going to be doing over the next few weeks is putting on some online training for teachers, teaching assistants, NQTs, and so on. I'll be giving details of all those tomorrow on my tomorrow's video. So it'll be absolutely lovely, as I mentioned back in the classroom, if you could tune in and I'll take you through all the things that I'm planning to do over the next few weeks and beyond that as well, into the summer and moving into the autumn term. Quite a lot of things that I'd love to share with people that I hope you'll be interested in. But for the time being, I do hope I'll see you tomorrow for that little mini video with an explanation of what's coming next. And then, as I say, I hope to see you in the future for the online training and for the mini videos that are coming up on resources. Thank you so much for watching all the videos over the past few weeks, and I'll see you all soon.